So the way I'm going to review for the exam, I'm going to go over review problems, and let's see how many we can solve. So let's look at the first one, how to find asymptotes for a rational function. So let's say we have y equals x squared plus 4x plus 6 over x minus 1. How do we find the asymptotes for such a function? So write it down first. Try it for 1 minute. So how do we do this one? First thing we set the denominator equal to 0, x equals 1. This is a vertical asymptote. So now the function has to have either a slant or a horizontal asymptote. So that was the vertical asymptote. Now for the slant or horizontal, it depends on the degree of the top and the bottom. Notice how the degree of the top is bigger than the degree of the denominator. So this means there's a slant asymptote. How do you find the slant asymptote? To do so, we do long division. We divide the top one by the denominator. What goes on the top? X squared minus x. Then we change the signs from negative to positive, positive to negative, and that gives us 5x plus 6, then plus 5, x minus 5, and then switch signs, you get 11 as a remainder. So whatever we get on the top, this is our slant asymptote, SA. We review now the composite functions. Composite functions, they give you two functions usually. Let's say like 3x squared plus 5x plus 4, and g of x is negative x plus 1. And we are required to find, let's say, f composed with g of x. So that small circle means composed with. So what would that be? Well, to do this, the composition definition here is, it means f of g of x. That's what this means. So then, to finish this up, we start with the inside one, g of x, and we substitute it in. So we get to this one. Now all we have to do, go back to the function f, because that's what we have, and replace the x. Notice how it was f of x and now f of negative x plus 1. Replace x with negative x plus 1. So that gives us 3 times negative x plus 1 square, 5 times negative x plus 1 plus 4. 3 times this one. To expand this, we use the formula a plus or a minus b squared. It's a squared minus 2ab plus b squared. So you square the negative x minus 2 first times second plus 1 square. Here distribute the 5. Then 3 times, this is x squared minus 2x plus 1. Keep this the same, that's a 9. Multiply the 3 in. So that gives us 3x squared minus 11x plus 12. What about if we do the other way around? They ask us g round f of x. Again, by definition, this means it's g of f of x. And f of x was given as negative x squared, or no, it was 3x squared plus 5x plus 4. Yep. And now we go back to the function g. And remember, on the side I'm gonna rewrite g. G was negative x plus 1. So we're gonna replace the x with all this quantity. So all this will go there. So pay attention to the negative sign. You put all that quantity for x plus 1. Multiply the negative sign in. That's about composite functions. Next one is about inverse functions, inverse algebraic functions. So how do we find the inverse of a given function? So how to find the equation of the inverse? To find the equation of the inverse. Let's say we take y equals x plus 1 over 3x minus 2. How do you find the equation of the inverse? Well, to find the equation of the inverse, two steps need to be done. Switch x and y, and then solve for y. Switch x and y and solve for y. So here I'm going to make every x, y, y, x. And now we need to solve for y. How do we solve for y? We cross multiply. X times 3y minus 2 equals 1 times y plus 1. Distribute the x, 3xy minus 2x equals y plus 1. Then bring the terms with the y on one side, so subtract y on both sides and add 2x on both sides, like that. So you must bring the terms with the y terms with them to the left side. Then factor a y out, so 3x minus 1. From here to here we did factoring. Then divide. So originally, if this is called f of x, this would be the inverse. Recall, the equation of the circle is given by x minus h squared plus y minus k squared equals r squared. This is the equation of the circle. Centered at hk and radius r. So we can ask you find the center and radius for x plus 3 square plus y minus 5 square equals 81. So for the first one, the center would be what? -3, pay attention to the signs, and 5. And the radius, always the square root of this quantity here, or the number. Try the next one. Center for this would be 1, -4. Radius is the square root of 25, which is 5. Next topic to review. We know the quadratics ax squared plus bx plus c. This could be opening up or down. There is a point here called the vertex, V. How to find the coordinates of the vertex? We have a shortcut, luckily enough. To get the x for that is always -b over 2a. -b over 2a. After you do this, then substitute to find the y value. For example, let's say y equals -2x squared plus 8x plus 1. We need to find the coordinates of the vertex. How do you find the coordinates of the vertex? We use x equals -b over 2a. I would write down ab on the side. A is -2 and b is 8. So if we substitute them into this, -8, 2 times -2. That's a -8 over -4, which is 2. So we found the x, but that's not enough. We need the y value as well. So what do? We substitute that back in here. So then the y would be -2, 2 for the x, square, plus 8, 2 plus 1. Y equals 4 times 2 is -8 plus 16 plus 1. That gives us 8 plus 1, 9. So the vertex has coordinates 2, 9. Next, let's say we are given a function 3x cubed minus x squared plus x plus 7, and let's make it ax, and f of -1 is 5. Find the value of a. So let's go over it. So all we have to do is substitute. This is the x value, and that's the y value. This is y. So 5 equals 3 times -1 to the third minus -1 squared plus a times -1 plus 7. So what do we get here? 5 equals -1 times 3 is -3 minus 1 minus a plus 7. Combine like terms here. 7 minus 3 is 4, minus 1 is 3. Subtract 3 on both sides. Multiply by negative. Logs if you remember, just recall some properties of logs. Log x base b is m is equivalent to, say, b to the m is x. That's the definition of log. If you have log, say, f of x, anything here, base a equals log g of x base a, this is equivalent to, say, f of x equals g of x. Log x times y, the product becomes sum, and the quotient becomes subtraction. Also, log x to the m for any base a, you can bring m down. What about if we are asked to solve an equation like this? So how do we solve such equation? Notice the bases are the same. By the above one of the above properties, we can set 7x minus 1 equals 3x plus 7. Subtract 3x on both sides. 4x minus 1 is 7. Add 1 to both sides. Divide by 4. And if you substitute this back in, it should work. I want to review what we call piecewise functions. Let's say we are given a piecewise function like this. Actually, let's make it x equals u. So if we are given a function like this and we're asked to find part 1, f of 0, f of 4, f of negative 1. So for f of 0, where do we substitute? The conditions are on the right side. The conditions are saying if x exactly from negative 1 to around 0, you use the first one. If x is 0, use the second one. If x bigger than 0, use the third one. You can't use all at the same time. So for this one, it says x equals 0, so that matches the second one. So the y value would be 2, as it's given. This one, x is 4, so that's bigger than 0, so we use the last one here. F of negative 1, that's the first one, so you replace x with negative 1. 1 plus 1, 2. Now how do we graph it? Let's graph the first one. Y equals negative x plus 1. It's a straight line. X, y, the origin. So when x is 0, y 1, y 0, x 1. So it goes like this. But the condition said only graph it from negative 1 to 0. So if you project it up, we can't have that part. We can't have. So we have to raise this part. So that's the graph for the first one. The second one, when x is 0, y 2. It's just a dot right there. Next one, it's a parabola that goes this way, but it's above 0, so we have to have an open circle there. So that would be the graph. Now, how to solve inequalities. Let's say we have x minus 2 over x squared minus 9 less than or equal to 0. So how do we solve such inequality? We use number line. Number line is the easiest way. So this one you can first rewrite it by factoring the denominator, x minus 3, x plus 3. What goes on the number line? Negative 3, I see 2, and I see 3. We can pick testing points. Testing points such as maybe x equals 4 and substitute here. That will give us a positive. If you pick something here like 2.5, that will give us positive, negative, positive, so that's a negative. and then that will turn out to be positive and this negative. The question is asking, when is it negative? When is it less than or equal to 0? It's less than or equal to 0 from negative infinity to negative 3. Now, we cannot include negative 3 because it's in the denominator, so we put a parentheses, union 2 to 3. 2 is okay to have a bracket because it's on the top, but 3 must have a parentheses because it's in the denominator. Always at negative infinity and infinity we have a parentheses. Next one, for the polynomial, f of x equals 12 x to the third, x plus 6, x minus 2/3 to the fourth power. We need to identify the zeros and their multiplicities. So to find the zeros, all we have to set f of x equals 0. So the 12x cubed times x plus 6 times x minus 2/3 to the fourth power equals to 0. Of course, 12 cannot equal 0, but you can have x to the third 0, or x plus 6 0, or x minus 2/3 all to the fourth power equals 0. Now to finish this up, this would give us 0 multiplicity 3, means it repeats 3 times. The next one, x equals negative 6 multiplicity 1, and the last one, x equals 2/3 multiplicity 4. Any questions about this? Next one, we can ask to solve a system of equations like this: x squared plus y squared equals 10, and y equals x plus 2. This is a system of two equations where quadratics is involved. The easiest way to solve such equations is by substitution. So you take the y equals x plus 2 and substitute into the first equation. So that becomes x squared plus x plus 2 squared equals 10. Don't forget the a plus b squared formula. A squared plus 2ab plus b squared. So this stays the same. Expand this using the formula x squared plus 4x plus 4 equals 10. We can combine the 2x squared, the 4x, and subtract 10 on both sides. Then divide everything by 2. And then what we do after that, we try to make sure this thing works here by factoring x. If it doesn't work, you can use quadratic formula. It's plus 3 and minus 1. So that works out. So you get x equals negative 3 and x equals 1. Don't forget to find the corresponding y value. So the y value, x plus 2, y equals x plus 2. That's a negative 1. X plus 2, 1 plus 2, 3. So we got 2 points or 2 solutions, negative 3, negative 1, and 1, 3. When we solve system of quadratic equations, we do need to check if this works or not. So let me rewrite the system again. X squared plus y squared was 10. Y equals x plus 2. So you can substitute this first one in. Negative 3 squared plus negative 1 squared. Does that equal to 10? 9 plus 1. Yes, it does. It works for the second equation. And it must work for the second. It works for the first, must work for the second. For the second, y is negative 1. Does that equal negative 3 plus 2? Negative 1 equals. So this is a solution, so we can box it. We do the same thing for 1 comma 3. X is 1, y 3. Substitute 1 squared plus 3 squared. Is that 10? Yes. Substitute in the second one. 3, does that equal to 1 plus 2? Yes, it does. So we have 2 solutions. How about solving 3 equations in 3 unknowns? Something like this. 3x plus y minus 2z equal to 0. 2x minus 4y plus 6z equals 2. Well, no. Can I change the problem? Because this will end up having no solution. Let's get rid of this and maybe make that 3. So this is from section 11.3. How to resolve system of equations in 3 unknowns. We do not want just to see the final answer. We need to see the steps. So for this one, it's up to you to eliminate one of the variables, either the x or the y's or the z's. We can eliminate the y's if you like. So I'm gonna pair these together. I need to multiply the second equation by 2, so you get 6x plus 2y minus 4z equals 0. That will eliminate the y's, so 7x minus 7z equals 1. I got one equation. And I'm going to take the last 2 together and just really copy them down, because the y's will cancel each other as well if we add the 2 equations. 5x plus 4z equals 3. I got another equation in x and z. Now we can solve these 2 boxed equations. 7x minus 7z equals 1. I'm copying them down. Let's say I want to eliminate the z using elimination method. You multiply this by 4 and this by 7. That will take care of the z's. So we get 28x minus 28z equals 4. 35x plus 28z equals 21. Add them up, these cancel, and we get 63x equals 25. So x would be 25 over 63. Then you can take this, substitute here, find the z, whatever the z is going to be, and then go back to the original equations and find y by substitution. Is that okay? Now I want to review conics. First, the parabola. In parabolas. So parabolas, if you remember, let's say I draw a parabola like this, that's the vertex. There was a focus in there and a directrix in here. If you connect all of them, this distance equal to this. It's we call it a distance or absolute value of a. This has h comma k. There were two different forms of equations. The first one was x minus h squared equals 4a times y minus k. So this depends on a. If a positive or a negative. If a positive, opens upward. A negative opens downward. The other one was y minus k squared is 4a times x minus h. Again, that depends on a. If a positive or a negative. A positive means it opens to the right side. A negative to the left side. How do we apply them? Find the equation of the parabola. Focus -2, 4, and directrix x equals 4. So the key to solve all these conic problems is to plot the given. Plot the given information and you will see what you need to do. X equals 4 is a vertical line like so. This is 4 here. And -2, 4, 1, 2, 3, 4. It's up here. So the vertex will be halfway through this, which is at 1 comma something. That's the vertex. So it's going to go up this way and this way. So the vertex is 1 comma 4. One comma 4. So this is h and k, and we need a, the distance a. A is the distance from here to here. What is that? 1, 2, 3. A is 3. And keep in mind it's opening to the left, so it has to be negative. So when we substitute the values in, the formula would be the y minus k k squared is 4ax minus h. So now all we have to do is substitute y minus 4 squared, 4 times negative 3, x minus 1. As one last step here, we multiply this to get negative 12x minus 1. We don't have to expand, that's all you need to do. Try another one. If the vertex is negative 2, 3 and the focus 0, 3. Find the equation. So let's do this one. Again, plot the given will show you everything you need. Negative 2 and up to 3, that's the vertex. 0, 3 is the focus. So the parabola is going to open to the right. The distance from here to here is a. So a is 2 here, and it has to be positive because it opens to the right. We have h comma k. That's all we need. A, h comma k. Since it opens to the right or left, always we use y minus k squared equals 4a times x minus h. So y minus 3 squared is 4 times 2 x minus negative 2. This stays the same. This is 8 x plus 2. Is that okay about parabolas? Now ellipses. Ellipses, if you remember, ellipses, let's say it goes this way. There are two axes we call major axis and minor axis. Call this V1, V2. These are the vertices, V1 and V2. So V1, V2 has a length of 2a. Each one is a. V3, V4 called co-vertices. V3, V4 has a length of 2b. This I is the center. H comma k is the center. And we have the foci on the major axis. Foci like that. We need to know that c squared is a squared minus b squared, the relation between a, b, and c. So to recall what these are, this is b, b. The distance from here to here is c, from the center to here is c. So in ellipses, a is always bigger than b. And the equation of the ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. If a is below the x, then it opens horizontally like this one you see. If a below the y's, it goes parallel to the y-axis. It goes parallel to the y-axis. So let's take an example. Let's say x minus 1 squared over 36 plus y plus 1 squared over 16 equals 1. So here the center 1, negative 1. So we have a squared is 36, a is 6, b squared is 16, b is 4. This is a squared, this is b squared. From these two, c squared is a squared minus b squared. 36 minus 16. C squared is 20. So C is the square root of 20, which is 4 times 5, 2 square root of 5. So I was able always from the given conic, no matter what question you are being asked, find the center A, B, and C. This is really the first step, to find those 4 things. A, B, C, and the coordinates of the center. H, comma, K. Then whatever the question is asking us to do, using this, plotting them on the graph, you will be able to solve any problem related to either hyperbolas or ellipses. The same way. Now we're going to plot this point, negative 1, negative 1. That's the center I. Notice the bigger number 36 is below x in the blue equation. So it's going to open horizontally to the x axis, parallel to the x axis. So from here you're going to go 6 units. 1, 2, 3, 4, 5, 6. So that lands at 7. And you go this way, 1, 2, 3, 4, 5, 6. Negative 5. B is 4, so you're going to go up 4. 1, 2, 3, 4. And down 4. 1, 2, 3, 4. Yeah, it looks like almost a circle. So that's the ellipse. We drew it. If I want to find the foci, the coordinates of the foci, you can connect these together. So from I, we travel C distance to the right. So C is 2 root 5. So it's going to be, let's say, I don't know, randomly here, F1. So F1 has coordinates 1 plus 2 root 5 for the x value, and the y is the same y value as I, which is negative 1. If you travel to the left, say here somewhere, so then F2, it's 1 minus 2 square root of 5 comma negative 1. Those are the foci, F1 and F2. If you want to find the vertices, call them V1 and V2. V1 has coordinates 7, negative 1. V2, negative 5, negative 1. I recommend using a graphing paper. It helps to see it better than the way we have it here. If you're asked to find the covertices V3 and V4, V3 has coordinates 1, 3, and V4 has coordinates 1, negative 5. This is what we included on the final for the algebraic part. Now we can review in polar. If you remember, if you have a point here, x, y, r theta, which is also equal to x, y, x, y, theta, r, we know that x is always r cosine theta, You need to know y equals r sine theta. We have x squared plus y squared equals r squared. And y over x is tangent theta. Those are the only four relations you need to know that will help you to convert from rectangular to polar and vice versa. Let's say we are asked to convert an equation. So they will give us an equation to convert that equation into either polar or rectangular. Let's say r equals 7 cosine theta minus 2 sine theta. So this means it has r theta. This means it's polar. We need it in rectangular. Or it could be y equals like x plus 7. That's in rectangular. We need it in polar. So the easiest way to solve the first one, I see sine and cosine. But if you look at all these formulas that we have here in the box, all sine and cosine attached to r, they have r in front of them, r cosine, r sine. So a good method here is to multiply everything by r. So you get r squared equals 7r cosine theta as the first step, 2r sine theta. So now what is r squared? Is x squared plus y squared. 7, r cosine theta is x. 2, r sine theta is y. So now what I did, I converted everything from polar to rectangular. Next one is xy. We need to get it into r theta. What is y? Y is r sine theta. What is x? R cosine theta plus 7. That's all you need to do. No more x, no more y. That's in regard to polar. Now trig. If we have in general a sine or a cosine like this, a cosine, bx plus c. We need to know what is the amplitude, period, how to calculate the period, phase shift, so the amplitude is always the absolute value of A, the period is 2 pi over the absolute value of B, and the phase shift is basically you solve this equal to 0. Solve for x. So x equals negative c over b. That's the phase shift. So if we ask you find all of the above, for y equals 2 cosine 8x plus 3 pi minus 1. Y equals negative 8 sine 2x minus pi over 4 plus 8. So the way this works is the amplitude here is the absolute value of 2, which is 2. The period is 2 pi over 8, which is pi over 4. And the phase shift is basically solving for x. So you can do that on the side. Negative 3 pi over 8. For the lower one, the amplitude, absolute value of -8, which is 8, period, 2 pi over absolute value of 2, which is pi, and the phase shift is pi over 8. It's like you solve this equal to 0. 2 pi equals pi over 4. If you divide both sides by 2, the 4 becomes 8. Now let's look at, I'll come back to the grading. Let's look at if they give us sine alpha, let's say 2/3 alpha in the second quadrant. Cosine alpha is, let's say, square root of 5 over 4, and actually beta, and beta is in the fourth quadrant, 3 pi over 2 to 2 pi, and they ask us to find, let's say, sine alpha plus beta. So sine alpha plus beta has a formula: sine cosine plus cosine sine. So for alpha, we draw a triangle per angle, one right triangle, alpha beta. Sine is the opposite over the hypotenuse. By the Pythagorean theorem, 9 minus 4 is 5. And we are in quadrant 2. Alpha is here. Beta in here. Cosine beta is given. Beta is from 3 pi over 2 to 2 pi. Cosine adjacent over the hypotenuse. By the Pythagorean theorem, 16 minus 5 is 11. So then from the right triangles we can get sine alpha is given 2/3. Cosine beta is given square root of 5 over 4. Cosine alpha, cosine is the adjacent over the hypotenuse, and it's in the second quadrant, so it should be negative. Cosine is negative there. Sine beta is the opposite over the hypotenuse, and it's in the fourth quadrant, so that should also be negative. Two square root of 5 over 12 plus square root of 55 over 12. The LCD is 12. 2 square root of 5 plus square root of 55. Make sure to review law of sines and law of cosines. To help in solving triangles. Solving triangles means find missing angles and missing sides. Also, how to prove identities. Prove identities. In proving identities, I can say guidelines for that. Always take the larger side and get to the smaller side. One of the things that helps you prove identities. Do not work on both sides at the same time. Just work on one of them only. If you have to do rationalizing. You can rationalize. If you want to factor, you can factor. If you want to expand, you can expand. One thing that a tool that helps a lot, always convert everything into sine and cosine. Convert things into sine and cosine. Okay, you guys wrote that down? Let's say, for example, they ask us to prove tangent alpha cotan alpha minus sine square alpha equals cosine square alpha. As you can see, the left side is the larger side. So I'm going to take the left sides to start with. Let's see how we're going to get to the right side. Convert everything into sine and cosine. This is sine alpha over cosine alpha. Cosine alpha over sine alpha. Minus sine square alpha. This cancels. This cancels. You got 1. 1 minus sine square. What's 1 minus sine square? It's cosine square. So that proves it. So don't touch the right hand side. Don't do any work on the right side. Also, the formulas to solve trig equations. If you have sine alpha equals sine beta, alpha equals beta plus 2k pi. Alpha is pi minus beta plus 2k pi. K integer. So if we want to review the cosine one, cosine alpha equals cosine beta if alpha equals beta plus 2k pi, or alpha equals negative beta plus 2k pi, k integer. So if they ask us to solve cosine square alpha minus 4 cosine alpha plus 3 equals 0 over 0 to 2 pi interval. So how do we solve such equation? First thing we do is factoring, since it's quadratic. So cosine alpha, cosine alpha. The 3 can be 3 by 1, but both should be negative because the middle sign is negative. So it's minus 3 minus 1. So this factoring works good. So in order for this equation to be 0, the first one has to be 0 or the second one has to be 0. Based on this, we know this doesn't work, since cosine, any angle is going to be always between negative 1 and 1. It can't exceed 1. So there's only one equation I have to deal with. Cosine alpha equals 1. What's the angle is cosine 1? That's a 0. The smallest positive angle, or the smallest angle, let's say, from 0 to 2 pi is 0. If you want to use the formulas I gave you up there, alpha equals beta plus 2k pi, or alpha equals negative beta plus 2k pi. But there's no negative 0, so this equation is not necessary. So you get alpha equals 2k pi. But don't leave it like this, because they said alpha is between 0 and 2 pi. So what you start doing, taking k equals 0, you get alpha to be 0, that's one of them. If you take k equals 1, you get alpha equals 2 pi. That's not part of it because it's a parentheses. If you do negative, you will get negative values. So there's only one value we get for alpha. Alpha equals 0. If we need to take another one, 2 sine squared theta minus 3 sine theta plus 1 equals to 0. So what do we do here? We factored out 2 sine theta minus 1 minus 1. So sine theta is 1/2, sine theta is 1. So the two equations are okay to solve. And then here, for the first one, that's sine 30 degrees or pi over 6. For the other one, sine theta is sine 90 or pi over 2. So theta equals beta plus 2k pi. Theta equals pi minus beta plus 2k pi. Same thing here. Theta equals beta plus 2k pi or pi minus beta plus 2k pi. All these k's are integers. So let me step back to the equation here. Say we are solving from 0 to 2 pi over 0 to 2 pi. So let's see what we get. Theta is pi over 6 plus 2k pi, or theta equals 5 pi over 6. For this one, you get pi over 2, which matches the above equation, so we don't need that. Now, if we take k equals 0 into all of them, that will give me pi over 6, 5 pi over 6, and from the equation up there, it will give me pi over 2. I get these three values so far. If I take k equals 1, it will exceed 2 pi in all of them. If I take k equals -1, it will go to the negative. So only three values. These are the three values that would work for that equation. Any questions about this? Okay, so now let me talk about the grading. So the way you calculate your grade, you just take exam 1, exam 2 scores, exam 3 scores, exam 4. You take the homework, everything you earned so far in the homework, plus, let's say you finish all the extra credit. It depends, you can estimate what it is, and then you need to divide this by 1, 2, 3, 4, 5. That will give you your average in class. Now, if you don't want to do the average thing, it's totally fine. Just take exam 1 plus exam 2, exam 3, exam 4, all the homework assignments, and estimate the extra credit and see what the total is. Then you can go to the syllabus and check on the syllabus under grading, see how many more points you need to get on the final to get an A or B or C. That's the easiest way to calculate this. Any questions about grading? So there will be a total 20 questions. 20 questions on the final. And I think the final was 200 points. So you expect 10 points per question.